Hello, and welcome to another episode of the Daily Bolt with your host, Dr. Jeff Tilley. Today's topic, Hurricane Isaias, Tropical Depression 10, and a Stonehenge mystery solved. Sit back and relax and enjoy today's edition of the Daily Bolt. So yesterday I promised some of the science news that popped up yesterday. We talk about it today, and so I'm going to actually start with that, which is the Stonehenge mystery that's solved. This news came out of England yesterday, according to new research that's been done. Basically, a geological chemical analysis of the stones that actually make up the iconic World Heritage Site, with all the stones that are standing up. Some of them are at the top and balanced somewhat precariously. Some of them have fallen off. Some of them are missing. Nonetheless, Stonehenge has intrigued people for many, many centuries. We believe that Stonehenge was built around the time of 2500 BC or so. That's during the late Neolithic period. And it's been a World Heritage Site for quite some time. It's famous because the stones are aligned with the motion of the sun, particularly at the solstices in December and in June. The site is in southern England, near the town of Amesbury. So what's the mystery? I mean, there have been a number of mysteries that have been solved by scientists in the last couple of decades. In this particular case, what was one of the mysteries that had been unsolved until this new research is, where did the stones come from? It was not clear. They are so huge. These stones are as much as 30 feet tall, and they weigh as much as 25 tons apiece. And if you're in 2500 BC, it's not like you have heavy equipment that can move 25-ton boulders particularly easily. So it took an enormous amount of effort. The research that was published in the journal Science Advances took a sample of the rock that Stonehenge is made from. It's what's called a sarsen. It's a type of sandstone, and that's one reason why the stones have been slowly wearing away due to exposure to the elements over the millennia. They did a number of sophisticated chemical analysis techniques. And one of these techniques, what's called inductively coupled plasma mass spectrometry, it's a very sophisticated technique where it basically breaks down a sample into its component elements and determines the percentage that each element is actually making up the material. It's actually a technique that I have a little bit of experience with because it is also used for water chemistry. It's used for snow chemistry. It's used for many types of chemical analyses. It's not a cheap piece of equipment either. There's not that many of them in the world. It's very expensive to operate, and there's only maybe 100 or so people in the world that know how to really manage this equipment. So they took the Stonehenge sarsen sample, and they took samples of similar sarsen boulders from across various places in southern Britain. And what they found is something that perhaps is a conclusion that makes a certain amount of sense, perhaps not. They found that the stones at Stonehenge match the sarsen that was located about 15 and a half miles away in the English county of Wiltshire. And it was the exact chemical match they found that led them to this particular conclusion. So even though these are still imposing rocks, and if they were carved at all, then the rocks were even bigger to begin with, it's still an imposing distance in 2500 BC to haul a huge rock. Nonetheless, it's not like it came from Scotland or some distant shore. It was relatively local. a place where you can get to on a bicycle from Stonehenge in probably a couple of hours, maybe a little less, depending. So it was local stone. So that's one mystery. Now we turn to the other science news of the day, which is tropical storms or hurricanes. And Isaias became a hurricane within the last 24 hours since I talked with you. In fact, it became a tropical storm first, late last evening as expected, and it quickly intensified during the morning hours this morning into a Category 1 hurricane, where it has basically maintained that intensity pretty much through the rest of the day with a little bit of up and down in terms of the intensity. Right now, as of 8 p.m. Eastern Daylight Time, the center of Isaias is just south of the Central Bahamas. The storm has been impacting the Central Bahamas for some time. It went through the southeastern Bahamas earlier in the day, and it is moving to the northwest at about 15 miles an hour, which is still a relatively good pace for a hurricane to be going this far into the western Atlantic. And as a matter of fact, the system has been stronger than expected. Not super stronger than expected. It was expected to become a strong tropical storm by this point. It's a slightly more than a marginal Category 1 hurricane. And it has continued to go a little bit faster to the west than originally expected. The implications for this are the fact that the forecast tracks and the envelope of tracks that are put out by the National Hurricane Center based on an ensemble of a dozen or so models have shifted to the west, and now the storm's track is going to be substantially close to the Florida Peninsula late tomorrow evening through Sunday and into the wee morning hours of Monday. That also has implications for the track up the rest of the eastern seaboard. It does look like it will also make a relatively close approach to the South Carolina coast and potentially affect the Piedmont, Mid-Atlantic states, and New England as well, a little bit more directly than had been otherwise thought. The good news is that it does not look like this is going to become a major hurricane. It looks currently, in terms of the forecasts, like it will maintain hurricane intensity as it makes its passage close to the east coast of Florida, but then start to weaken as a large area of low pressure aloft gets close enough to start affecting not only the track of the storm, but giving what we call vertical wind shear impacts onto the storm itself. Now, it's interesting in that we have two competing effects for this particular hurricane. Ocean water temperatures throughout the Bahamas, along the east coast of Florida, and the Gulf Stream are a little bit warmer than normal for late July, early August, anywhere from about half a degree to almost 2 degrees warmer. And that would tend to favor additional intensification of the system, and certainly while it's going through the Bahamas, additional intensification is expected. It may reach Category 2 status for a while, but it is unlikely to maintain it because of this approaching area of upper level low pressure, which brings this vertical wind shear. As I've talked about in podcasts in previous years, with tropical systems, vertical wind shear, the stronger it is, the more it affects the structure of the hurricane, and it cannot act as efficiently as the heat engine that a hurricane actually is. And if it does not get that efficiency, it tends to weaken. So you have a weakening effect and a strengthening effect both as the storm moves close to the southeast coast of the U.S. Whether the storm actually makes landfall in the Carolinas remains to be seen. That would be the most likely place it will make landfall at this particular point. If the storm progresses just a little bit farther west, it might be a different story. We might see more land area affected. But that's going to become much clearer by this time tomorrow. Also, just to mention, this is not the only Atlantic tropical system to watch. There is a new tropical depression that has formed off the west coast of Africa near the Cape Verde Islands. That's a very typical place for a tropical system to form. It's going to be quite a few days before that impacts anything other than the shipping lanes. So I'm just going to say it's there. It'll be something to watch over the next few days, but it's nothing to worry about for the time being. Tomorrow we'll update you on the hurricane and whether there's any updates to the tracks and any other science news that comes upon us. For now, I'm Dr. Jeff Tilley. This is the Daily Bolt. Have a good evening, good afternoon, good morning, and stay safe.